No question. I think we will have a question later. Thanks, Dieter, again for this very inspiring presentation and to introduce us to the future of augmented reality, not only what we did inside the project. It's now time for Aalto University. Antti Numinen, the coordinator, will now introduce us to his specific team of research. Antti ci introdurrà al suo specifico tema di ricerca, prima ci ha presentato il progetto in generale, ma oltre che coordinatore del progetto, Antti ha lavorato a una specifica parte di sviluppo, in particolare alla realizzazione delle mappe 3D. Quindi il titolo del suo intervento sarà 3D in CultAR and Trends for Future Exploitation. Thank you, Antti.
Thank you. Okay, so my topic is 3D maps. If you think about creating an expression of your environment visually, how would you do it? Humans are really accustomed to seeing through their eyes. So you would like probably do a drawing of your environment, but if you want to have a larger environment, how would you do that drawing if you cannot fly? It becomes quite a challenge how to represent your environment in larger scale or even smaller scale. So already 2000 years ago they were thinking about how to make it happen, and they realized that there are two parts. You do measurements of your environment and then you render it. And the measuring part itself was considered to be something of a real science of its own without really technological tools for that. And they created a global coordinate system for that. And if you look at map data 2000 years ago and map data of today, it's the same more or less. Same latitude and longitude already there. And now it's a little bit more accurate. And then again, you can render that same data in different manners. For example, 2000 years ago, the Greeks didn't really like to put any decorations to their maps, and later on these kind of Ptolemaic maps are familiar because of the decorations, but they themselves didn't like it at all. But there's always some liberties how you use your map data and how you create your representations. Romans tried to address that problem of scale. They made a very accurate map of the Rome itself, hacked that on marble, 18 by 13 meters. It's not very good for mobile use when just that one fragment on the left weighs about 70 kilograms. So you can't carry that kind of 18 by 13 meters marble block around with you. Well, okay, that was for small scale. What about if you travel within the Roman Empire and you have all the Roman roads there? You can render that Roman road dataset into, for example, a parchment, which was a suitable medium of the day. Then you have this tabula peritingara, which is like 7 meters long, 34 centimeters wide. Again, this is not something you can create for any tourist in the Roman Empire. Very special rendering of the Roman road network. And you wouldn't use that normally as your carry-on mobile map. So instead, if you know where you're going, if you're going to Rome, for example, you create just a list of towns, an itinerary. So on the right-hand side, you have the real Roman mobile map, which is an itinerary, a list of cities through which you would travel to reach Rome. Then again, you have the problem of scale. Now you have to rely on the road map, road data, that you actually find these cities on your way, but no way you could have the whole Roman Empire hacked in marble and carrying it with you. It would be the size of the Rome. So it was a problem, it still is. However, 2000 years later, we realized that maybe we have these nice electronic devices and we can finally render our environment in a similar manner as we are used to, in a three-dimensional realistic manner, exactly as it is. So Professor Rakkolainen from Tampere, Finland, tried it first on the good old PDA devices, if any of you remember those devices from 15 years ago. They created a city model of Tampere and tried to render it. No way, you couldn't fit it into the memory. So they cut away most of the city from the nice model and had a small piece remaining, and that they were able to render once every 8 seconds. And they thought that maybe in future it will become better. So now, ladies and gentlemen, we are in the future and we have tablets. So we can actually render that nice city of Tampere or the city of Padua on our tablets. However, again, we are faced with the problem of getting that data set, how to render the data set. For Padua, we were really happy to receive a very accurate CAD model of Palazzo della Ragione, created by University of Venice, which we then took and simplified and textured and made it into part of our small city model. But this is still something that's very, very resource demanding, and humans have to create such models. We really hope that automated means would make such modeling possible. Right now, automatic means are available, but not at this level of quality. For CultAR, we collaborated with Community Padua in creating a part of the city, given our limited resources, and we're able to create a few areas of the city center which we can use now for the project purposes. So we started up with the CAD model, and then we created these quite simple blocks which we textured with digital photographs which were made by CDP. We can use now these 3D models of Padua to travel around, navigate in there, but also to annotate. So 3D maps are very good for creating 3D-dimensional annotations. The problem of that is that current data sets are still very traditional. You have latitude and longitude like 2000 years ago. Nothing has changed there. And now you actually would like to pin those points of interest to the actual places, the actual positions in our environment. We created a specific tool where we take in the cultural content of Padua and place them into the model so that we can actually have them there. And again, this is something that we have to do manually right now because the existing datasets, cultural datasets of urban areas, they are not really intended for 3D use yet. It's interesting that we actually can do it very accurately. So one specific feature of these higher quality 3D models is that you can really pinpoint your target, your point of interest to the actual visual position. So if you compare this to any usual 2D map, you couldn't even find out the vertical position on a facade of a building where this actual target is. But with the 3D model, this is possible. What I would see for near future of 3D maps is that we would start having more dynamic maps. Instead of just annotating our models with static information, we would use live data, real data emerging from the actual environment, sensor data, people moving around, vehicles moving around, and use a 3D model or kind of a data model that allows management of this kind of live data. In a simple case, for example, if we measure the quality of water from the environment, instead of providing some numbers on oxygen level or murkiness or conductiveness or whatever somebody wants to see, we can visualize that data immediately on top of the 3D model. We can render, for example, our environment based on the sensor data. So our 3D model becomes more dynamic and more closer to the reality. We can, of course, emphasize information. Here on the top, you see a water quality rendered based on the murkiness, for example. That means how much you have dirt in the water. If it's very clear, it's reflecting the sky. If it's kind of murky, which has a lot of dirt in it, it doesn't reflect. Very simple and should be easy to understand for people. Or we can color code temperature. If it's red, it's hot. If it's blue, it's cool, whatever. So the 3D model becomes more dynamic with sensor data from environment. In another case, we have a tracking system for this. Again, it's a city of Tampere, so this is actually the 15-year-old model they used there. And the McDonald's is still there for the next 1 or 2 weeks. It was the first one in Finland. It will disappear, so now we had to make a change to the city model. We track anyway in that city the entire fleet of public transportation and can visualize it also in the 3D model. I see this is one direction of 3D models where it's not just a static model, but you have to find ways to update it and update it really fast. The Romans probably had very tough problems in updating their marble map. If they tried to have something moving on the marble map, the refresh rate would be a few years, I think. Here we can hope to get something like 30 Hertz. One direction is, of course, which is very close to 3D maps, is the augmented reality that Professor Schmalstig just described. We are discussing the same thing. We have the user is looking at the world through a 3D model or through a video stream coming from it on the tablet device. And we can combine our 3D model and the real world. Professor Schmalstig just described how they create these point clouds, a representation of the environment. And both AR and 3D need to have the same registered understanding of the three-dimensional space. So, for example, here we have a small 3D model, and then we have automatically created a point cloud. And they, of course, should be in the same coordinate system. So once we do registration between these two different types of models, then we can have, hopefully, a combination of them. Let's see if I can make it run. Yes. So Palazzo della Ragione, reality, augmented reality, 3D model, back to augmented reality, and back to reality. So this is one goal of the project, to combine these two technologies smoothly together. Okay. One small feature we have in the CultAR system is dealing with the visibility. For augmented reality system, if we populate our city with dozens of points of interest, it's difficult for the augmented reality system to know which ones are actually visible to the user. For a human, it's of course really intuitive. Okay, I can see this cafe, it's there. But for a set of points of interest in a database, you can do a search for proximity within 100 meters, but they can still be behind buildings. And if you overlay in front of your video stream, it could be confusing for the user. User will see the cafe label in front of the building, but it's actually behind the building. This is really confusing. So in CultAR, we can do a visibility culling process online, where we are still in the augmented reality mode, for example, but we use the 3D model on the background to do the occlusion test, if this cafe is actually visible to me now, or is it behind the building. So we use our 3D model in this manner, which benefits the augmented reality. So we have this nice harmony of these two technologies and combine them, take the best parts of each, and can users choose what they wish. I think I'm nearing at the end. Just want to say that 3D is now becoming really interesting feature everywhere. If you have 3D data, you can render it on the computer display or you can print it out. So one funny thing now is that you can, for example, print out the star systems. And for humans, just to have a tactile version of a star system can be more expressive than actually the rendering on the screen. So these researchers, they found new features from this Gaetano system just because they printed out different phases of that with 3D printers. Just a leap from our 3D maps to something completely different. Thank you.
Thank you. Thank you, Antti, for this very clear presentation. Grazie per questa presentazione. We will have questions later, as usual. There's now time for Anne Morrison. Here he is. From Aalborg University. Anne is a scientist, a designer, a performer. She did a great job inside CultAR, both with something developed in Aalborg, but also as designer of the vest that you see on the mannequin. And the title of her presentation will be Wearables in CultAR and Trend for Future Exploitation. Thanks, Anne, to be here and to introduce us to your product.
Thank you very much. Okay, hello everyone, and thank you for the lovely introduction, Luciano. We are a small lab in Aalborg University, and we've been working directly with wearables in this project. Of course, at the moment, there's a huge market out there with a lot of gadgets, particularly around fitness and assistive technologies. For this project, we've concentrated on navigation assistant, responding to feedback from points of interest in the environment, both here and in Aalborg, a second site. And we've been working with a wearable vibrotactile vest, which we see up on the stage here, a 3D audio solution, and a haptic glove, which will be covered by University of Helsinki. So one of the main priorities of the work we have is to calm and relax people, to activate them, to guide them in the environment, to inform them and warn participants, and that it's used for mobile navigation in an outdoor environment. Of course, it's a challenge to just work with vibrotactile information. It's also a challenge working with the body. We started with the idea that we would have a one-size-fits-all vest. It's quite a challenge in itself. We needed the vest to fit tightly to all curves of the body, and of course all bodies are very different, longer in certain parts and wider in others, with bigger and smaller curves. We wanted to help people navigate. We needed that it felt good to wear, that it wasn't restrictive, that it assisted with hands-free interaction in the environment. After the presentations today, we'll have demonstrations, so please, I invite you to come and try. We have 2 vests running, and there's a variety of versions. So we have the vests where you can have full sensations, calming, activating, and navigation, or navigation with audio and navigation solo. So we would really like you to come and try these. It's very different from just looking at them and very different from just thinking about vibrotactile on the body as some kind of buzzing that happens. It's a very full sensation. We've had various versions of the vest, and I'll run through these quite quickly. First, we started with a very soft cotton kimono that could be adjusted. We have an internal harness, so we could slide things along and adjust them on the body relatively easily. And what we see here is with the dots on the person where the actuators are actually located. The idea being that, for example, the patterns that we would have would emulate natural touch. So we have the idea of running the hand up or down the back to help calm, or around the waist to help also a feel-good sensation. Here we have people wearing it in environment in Aalborg, and this is this early second iteration of the vest with a padded outer shell of different sizes that would make sure that the actuators stayed close to the body. We had a variety of locations on the body and a variety of calming, feel-good, activating, and navigation patterns. Also a warning information pattern on the solar plexus, which would really instruct people to stop if there was some kind of emergency. This was part of a small opening event in Aalborg, and we addressed the site there, which was an old industrial area, which is being refurbished into a cultural precinct. The park itself was situated here, and we needed to address the aesthetics here of a site that's also beside the Utzon Centre, the architect who's also designed the Sydney Opera House, but also to try to ensure that people stayed longer in the park rather than just using it as a pass-through space. So we built an environment that was responsive to the vest, but also responsive to the needs of the passers-by. This is an interactive humming wall. It does literally hum. I'll show you in a video shortly. And we had various zones of the wall that were responsive when you were wearing a vest, differently to a passerby experience. It worked as a kind of a musical instrument. We had lots of people participating in pairs at a series of trials over 5 weeks, and I'll show you some of those kinds of interactions. Hopefully we're not too loud. Okay. Oh, we have sound issue again.
All right. That one? I do it. Yeah. It's like wearing one of those chairs. Yes. Okay, and again. And again. You can come along as you like.
Oh, I like that.
Okay, so new pattern coming.
Yeah. Oh, okay. Oh.
Oh.
It's actually releasing something.
One more advice.
Ooh. Yeah. Yes.
Yeah, but it's it has the same pace.
No, okay.
Yeah, there's no difference if you're fast or slow. Oh, I'm getting this. Ooh, it's down here.
Bring that up, bring that up.
Going up. Maybe I'm dead.
No, it's not going up. You have to go up 2 feet. It's 2 feet, yeah. Sometimes.
Come on, Hart. You can do it.
Ah, yes. Here we have it.
Are we going up?
Yeah, going up.
Okay, so you can see it also responded to physiological data from the wearer with a heart rate and a breath rate being shown at the wall, at various sites of the wall. We looked at what people responded to, and we had a very nice response to up and down patterns of the back and around the waist. And of course, stop and the activation patterns were not so warmly received, which is quite sensible, really, as they were not meant to be so pleasant. However, we wanted to work with that, and we looked at some of the confusion people felt, for example, with navigation. If we had, as you would with an elder, you would have a hand on the back and the waist, but when you have vibrotactile sensations in 2 parts of the body, it's confusing for the person wearing the vest. So we needed to work with that. We updated our harness firmware from this so that we had a much less intensive running situation, and we also looked at modularizing the vest, so there was less need for the long fitting sessions we'd had with this vest, and also that we could make a modular system for combining patterns differently. So you might have calming and warning patterns with a navigation, but you might have feel good and activation for another version. So this version we made up was looking at threading the electronics between 3 soft layers of material, and that would be domed together and fit on various sizes of bodies. We ran some lab tests here and found that we could actually work with the back in a much more substantial way than we thought if we changed the ratio of duration of patterns to the overlap. So if there was a 1 to 2 ratio, it was calming, but if it was, for example, 500 milliseconds with a 400 overlap between the millisecond overlap between the next actuator kicking in, it was much more activating for the person. And that was information that we needed to have in order to make sure that we could keep redesigning the patterns and working with those. At a certain point, we realized that one size fits all was just too hard, mostly in terms of the fitting. So we brought in some vests of various sizes, and these are what you see today, or versions of this are what you see today here. With a zip-up vest, with Velcro that you can position differently, etc., and making up we have a series of holders for the actuators so that the vibration is felt, but the sound of the vibration is dampened to some extent. And we also looked at modularizing the boards as well. So we broke down those aspects so that there was less weight on various parts of the body, etc. So, yeah. Okay, and this is how it looks in its sort of final laid out. And small, medium, and large, or we actually have extra small and extra large as well. And over the top of that, we place a stretchable, which makes sure that it hugs tightly to the body, and we have some other Velcro which can add to make sure that, for example, in the small of the back, that is held firmly against the body. I'll just show you a short video here of some corridor testing of the... And another one set in the courtyard in Aalborg, where we're testing it with a basic version of the CultAR app to make sure it's automatically maneuvering the person in the environment. So as you can see, some people are very literal when they get turned, and that was one of the things we were looking at. How close to the turn does it need to be before you give the instruction there, for the navigation instruction from the vibrotactile. We also are looking at 3D audio, and one of the things that we needed to look at was distances to points of interest in the environment, and how to make it clear to a person how far or near they were to a point of interest, with a 3D sound environment that we developed. And we have a very responsive 3D audio system, which would really like you to come and test with us. We have custom created audio clips that are generated also within our larger CultAR app database, showing points of interest with their titles and descriptions, etc. So you also have the beacon telling you where you are and location to the point of interest you're heading towards, and then information on that actual point of interest coming through your headphones. So again, I'd like to invite you to the demonstration afterwards. We'll leave from here, so it will be an organized, orchestrated thing, and there are the more intensive, full potential with all the different sensations, activating, calming, navigation, and warning information, or the guided monitor using the audio, or just with the vibrotactile, or just vibrotactile itself. And that's a system that will be navigating you within Padua environment. So please come and join us. Okay. Thank you.
Thank you, Anne. Thank you very much. And thanks also for the great collaboration among our university And thank also to Walter and Jack
Yes,
that visit our
yes.
lab. Was a great experience for all of us.